So good morning everyone. In this video we will be going to see about the simplified data encryption standard algorithms. So Sdes, which is your simplified data encryption standard. So data encryption standard is a simplified version of data encryption standard that is often used for educational purpose. So this helps to illustrate the basic principle of symmetric key encryption and the working of DES in more understandable way. That is, the main key features of this Sdes lies on the key length, block size, rounds and the key structures. So the key length can be 10 bits. It can be compared to 56 bits in DES. Next is the block size. So 8 bits compared to 64 bits in DES. Rounds, 2 rounds we can be compared to 16 rounds in DES. Key structure, 2 subkeys of 8 bits are each generated from the 10 bit keys. So Sdes uses the same overall structure of DES based on the feistel structure with substitution and permutation operations. So we just have an overview of this algorithm. First is the key generation. In order to produce subkeys for each round, encryption, which is using the generated subkeys, decryption is also using the generated subkeys. So here the main encryption algorithm involves 5 functions, which is an initial permutation. Here the 8-bit plain text undergoes an initial permutation which we rearranges the bits. First round, using the subkey K1, the permuted plain text is split into 2 halves. There is the left half and the right half. So here this is the key generation process. So here key generation, it starts with 10-bit key. We can apply permutation called P10, which rearranges the 10 bits according to the fixed pattern. Next we are splitting the permuted key into 2 halves, each with 5 bits. The left shift is on both halves. Apply another permutation called P8 in order to select 8 bits from the shifted halves. This will give the first subkey K1. Perform another left shift on both halves, left shift 2, and apply P8 permutation again. So this gives the second subkey K. And here is the encryption process. So on this encryption process, first step is initial permutation. The 8-bit plain text undergoes an initial permutation which rearranges the bit. And the first round, the permuted plain text is split into 2 4-bit halves, left half and right half. Next, the right half is expanded to 8-bit using an expansion permutation. The expanded right half is then XORed with the subkey K1. The result is passed through 2 S boxes, S0 and S1, which substitutes the 8-bit with 4-bit. The result from the S box is permuted using the P4 permutation. And the P4 output is XORed with the left half of the original block. The right half remains unchanged and the new left half is swapped with the right half. So in the second round, the same steps from the first round are repeated using the subkey K2, but without swapping the halves at the end. So the final permutation, after 2 rounds, the 2 halves are combined and inverse of the initial permutation is applied in order to produce the final cipher text. So the same reverse process is done on the done for decryption. Okay, so here the decryption. So in the decryption also, first we have to apply the initial permutation. Next we have to perform 2 rounds of decryption where K2 is used in the first round and K1 is where K2 is used in the first round and K1 is used in the second round. After the rounds, apply the inverse initial permutation, that is IP inverse, in order to get the original plain text. So this is how your Sdes will work. So these are some of the simplified version of Sdes decryption method. I hope you understand this simplified data version, right? So it is a that is, it helps to demonstrate the key generation, encryption rounds, and the use of feistal structures, which are considered as a fundamental to understanding the real world cryptography algorithms like DES and AES. So Sdes is not secure for practical application, but this can be used only for the educational purpose in order to understand the encryption, decryption, and the feistal structures. Okay, so hope you understand about the simplified version of DES, which helps to understand about only the DES. So this is not used in any real practical applications. So thank you.